This is a video demonstration of how to make use of the Robotous 200N 10Nm torque sensor. So the first thing you have to do is to navigate into this directory, which I believe you'd all have by the time you purchase the sensor. It's usually provided by the vendor. So in this situation when you're making use of USB connection, as evidently shown here, so you have to make use of this application. So all you need to do is to double click on this application here, and in this case take note that we are making use of the RFT_IF_UART, which is specifically for the USB connection. So there we go. Now, okay, so something very, very important is for you to configure your force and torque sensors in this case. So the configuration of the sensor we're using, this is the 200 Newton and 10 Newton meter torque sensor. So you have to change all these as it's going to affect the scaling of your plot. So after all this is done, and in this case my port number is 12 rather than 1, then you'd have that set. Then you click on open port, and most importantly also ensure that you set the bias, as this affect the readings will also be getting in this case. So click on set bias and then get force and torque sensor continuously. So based on the readings we are getting, we're having very small values, the average of the values is about it's around 0 Newton, and that of the torque as well, it's also around 0 Newton. So ensure you have these settings in place. You can also add some filtering in here, but in this case I won't be using it. So the next I'll be doing is to log the data so that I can filter it in MATLAB as shown here. So click on log, start logging data. So at this moment the data is going to be logged into MATLAB. Sorry, not into MATLAB, into a TXT file. Okay. Yeah, I'm going to stop the login at the moment. Okay, stop data logging. Okay, yeah, so there we go, our data has been logged. So at the moment there are no data here currently. So for you to verify if our data has been logged, all what you need to do is just refresh your file browser. So this has been refreshed, and okay. Yeah. Since I never got the data, okay, let me try it again. Oh, it seems I never even started the login in the first place. Anyways, not bad. Okay, my bad. The data were actually saved. Okay, yeah, it was actually saved right from the initial settings. But anyways, I'm just going to delete this and then have it done again. Okay, shift delete. Yeah, permanently delete these two files, and then here we go again, starting data login. And once I've taken sufficient amount of data, I'm going to stop the login. Okay, now I'm stopping data login for now. Okay, yeah. Okay, yeah, there we go. Here's the data we are using. So now to visualize the data in MATLAB, all what you need to do is to ensure that the label of this file here matches the name in which we have in here in MATLAB. So in this case we have 2025 1220 2025 1220 with an underscore of 004742 004742 my 4742, and yeah, here we go. Play. Okay, we will be getting data in a couple of seconds, I believe. Yeah, good. Here is the data. Okay, at the moment it's looking messy. Yeah, a lot I will have to do just to separate the data, and then you're gonna be good to go. Okay, so here's the MATLAB code. It has been updated to reflect the necessary information needed, and here is the plot separated into two different subplots in a single figure. Okay, so basically the mean of all the forces is around 0, which is basically what I'm expecting, because no load displays on the device. So yeah, this is all working good and all in perfect condition. Okay, so I guess this is gonna be all for now. See you later, and don't forget to subscribe to my channel. Bye.